favorite camerawoman Maria, who is behind the camera, making sure to capture every memorable moment for you.
We're at the Life Support Institute in Moscow, waiting for the microbiologist to join us. Let's wait in the car for a moment. Simple repairs?
Shouldn't
Be done by drivers.
And at the very least, it's extremely important to pay close attention to this particular issue. Like, for example, with those rods that ended up getting bent out of shape. Otherwise, honestly, I'm afraid to lower it. We actually had a situation just like this before when Nikolai switched over to being a driver and started coming into write in the Blue Book, which, by the way, is a logbook very similar to the one we use to make notes and changes in. Change the bulbs here, change the bulbs there, update the records. All right.
For now, send my regards in the video. Gentlemen drivers, if I or any of my trusted advisors see any dirt or debris inside the vehicle, not the kind from outside, I understand it's dirty outside, but things like household trash, cigarette butts, or similar items, if someone, for example, leaves these behind, it becomes a concern. Change bulbs as needed. Send my regards. Drivers, trash or smoking inside means a 10,000 ruble fine. Minor repairs and tire inflation included. Changing bulbs, like light bulbs and so on. Filing down studs, like what happened on the screen. You should do these things yourselves. Change bulbs and file down studs like on the crane. Do these tasks yourselves. If you can't, report it. Later questions like, it doesn't work, I don't know, may cost you up to half your salary. If you dislike the working conditions, we can't work together. If you have questions, ask your supervisor. This is my message to you so everything gets done. I'm tired of this. Hello, gentlemen. Welcome to the DPLA channel. We're visiting the Research Institute of Reinforced Concrete. We're here to protest. Hello, gentlemen. Welcome to the DP Lab channel. Today, we're going to visit an interesting place with you, the NIIZhB. Here in the lab, we'll be testing the cubes from the Dristnya 2 video. We'll also talk about glass fiber concrete, ultra high strength concrete for machine bases, and a lot of other interesting things. Professionals work here, so I hope they'll help and guide us. Well, shall we begin? Let's go. You said we were going to film. Oh, a Rubik's Cube. These are the special cubes used for testing purposes, for compression tests specifically. These are the ones we use. Let's go. We're here to film. Show me the cube. Oh, a Rubik's Cube. These are for compression tests. Even a concrete cube. Here's the entrance. Beautiful. Right now. Hello.
For some reason, yes, for some reason, people are either very protective or not at all about filming. They say it's a restricted facility, all that, but we're open
To everyone. There's absolutely nothing.
There is nothing supernatural about it. People are quite used to it now, yes. Here, the guys are working with various different composite materials, such as composite rebar. They use carbon fiber and fiberglass. For example, a sheet of carbon fiber, which is carefully glued together. This process requires precision. A profile is wound. It's not metal, it's carbon fiber and fiberglass. This is carbon fiber glued together with a wound profile. What do you think? Is it okay? I think it stretches. No, it doesn't match metal rebar. Here is standard steel rebar. It doesn't match. With metal rebar, you can bend any element, V-shaped, L-shaped. Here you can't. No, here you have to make the elements at the factory from the start. That's inconvenient because usually when construction begins, they set up a rebar workshop and bend whatever is needed right on site. But here there are certain issues with bent elements. As far as I know, this is well done.
Where there were no deposits on the rotor. We are now in the laboratory of NIIZhB, which is a well-known research institute. Here we are preparing to test the samples that you saw in the last video called Dristnya 2. These are the very same samples from which we made the pylons. By the way, the pylons have already been installed at their intended location. We made them using the P100 mix, which is a special type of concrete. Now,
let's see what
the actual
strength is what everyone wondered.
bets, B65, B80, B60.
Shall we go ahead and test it on the Instron machine? Well, actually, let's just test it out. This is the Instron company. I think it's British, right? Well, anyway, American, British. Imported, basically. Imported. Yeah, a real beast of a machine. It's really big. You can use it to test both the compression of various samples and the tension of rebar with sensors and all sorts of advanced stuff. Wow. On the explosive part. And more launches. We ourselves aren't quite sure what's going on with it, honestly. The problem and why I say it needs to be polished, it's because of this. Let's try another side. Is it critical? Keep the gravel mix moist. Polishing isn't needed for you. High-strength concrete.
It is absolutely critical. Yes, you really do need to, well, more or less the edge of the situation. Well, as a matter of fact, you know,
We'll see what happens, and then we'll do it.
We'll take that into account too, because by the way, I found Mikhail's cutting and grinding machine. I actually found one that was really made in Italy.
from Maltese,
Not even close.
don't come near.
Yes, maybe, of course. I'll crush a high-strength cube for you later, which will shatter impressively for a good shot. And here, did you find it? Have you bought it? Yes, there's a cutting machine at MGSU, and it makes 2 cuts at once. So, the sample? Yes, now we're applying the load. It's at 100 kilonewtons. Oh, wait. So now, at this point, we already have about, there will also be some background noise present here in the environment. Here we can clearly see the braking load that is currently being applied to the sample. As soon as the sample undergoes some destructive deformations, the graph will start to drop and the maximum value will be recorded at that moment.
Sample at 500 units, testing limit.
You can't see it, but the graph is leveling out. 600, that's 600 kilonewtons. Of course, it's stronger.
If it was in, as you can see,
The geometry, here we actually have some other factors as well, yes, such as these.
now to simply create, and just this,
We're just about to, in just a moment.
Test everything right now, even before.
Now we'll... Zhenya, could you please put a bucket underneath, if possible? I'm going to break it a little now. If you look at the standards, the classic failure of a sample should occur along 2 pyramids. Let's take a look now. Zhenya, please put a bucket underneath. I'll break it a bit. By standards, a sample should break into 2 pyramids. When it breaks, you should see 2 pyramids. Let's see. It broke correctly. You can see the edges, the little pyramids. Here they are. That's it. Others might be a bit better. Well, here they are, you know. Others might be a bit better. Here they are. They all break like this, right? This is classic. This means we've more or less achieved central loading.
If there was eccentricity, one edge would break, or
Something like that. So we should...
aiming that, here you go.
No, this is quite a strong material.
The storage conditions, where did you...
Store them? Nowhere, really. We just have ones with about 98% humidity, so to speak.
And here we have, well, basically, you know, every lab has chambers, such as these, in fact,
For normal curing, as they're called.
where the samples are briefly stored before testing. M600, M600.
$240 megapascals, 270 megapascals can be achieved. It will be made with a cement binder, but there will be specific aggregates. You can make it. The question is whether it makes sense, who actually needs it. Basically, when you add crushed stone In such high-strength concretes, it actually acts as a weakening element because its strength is already lower than that of the matrix material. As a general rule, concretes of such high classes are made without aggregate, meaning they are quite fine in texture and composition. They are called powder concrete. That's reactive powder concrete. Reactive. But this is already being used worldwide in the field of construction. For example, Lafarge. They make it for bridge structures, such as overpasses, as well as for tunnels.
They have a line of mixers
It's actually called ductile. They make it
for bridge structures, for tunnels, and so on. It costs a fortune. It's expensive, yes. You could take, I don't know, cubic boron nitride.
powder, use it as an additive.
Simpler. Here. Why? It's frozen here, obviously. And I'm on just this ductile, well, at least some kind of...
Silicon dioxide too. We use it there and make cast iron shot for gamma radiation protection. For example, reactors at nuclear power plants. Yes, that's where the crack starts. See, it's leaning to one side, a bit crooked, now pressing on one side.
It's being pressed on one side. And how much does this...
Press mag output. Yeah, you know, it really has. I mean, for sure, you know. No, but cleaning up afterwards takes a long time. The deformation there is tiny, just 0.6 millimeters. This measures the traverse's movement, so the deformation isn't significant. It doesn't really bend. The change is in the thousandths of a millimeter. Would granite be more precise? Polished granite from different sources gives different results. There are granites that showed 200 and some up to 2,000.
There are kilonewtons.
There are some that are 150.
Well, kind of. It is actually less strong than basalt, but it is still considered to be quite strong overall.
Something just cracked unexpectedly. The heavy load suddenly dropped, and it seems that something small chipped off right there. But it's still holding, right? Maybe it leveled out. And what's the target there? 470. Judging by the way it's breaking apart, the values aren't very high.
It just showed at what? That's right now. The maximum load on this particular sample, as you can see here,
and initially it showed 409, which was the previous data that we had recorded. So in your opinion, is it really off by about 30 or 40% compared to what we expected? Absolutely, yes, that's... So for us, it's like B50, B75, which is what we would typically expect in this kind of situation. Well, B75, yes, B7, B75, B... That's fine. Is it harder for you, perhaps? Let me know if you want. The guys need it here, otherwise they'll lose accreditation. They won't go. Such a drop is unacceptable. Now I'll just go ahead for just a little while.
On the field, the grillage. Well, 50 is also fine. What's there? What? 600? You can't
buy that.
You simply can't apply it. No one will actually sell it to you. They will sell it though.
How much?
We need, they actually won't sell it by the cupful.
They won't sell it.
It was really tough, of course. So what was the powerful thing that we actually wanted specifically?
To blow up?
Let's go. To the car if you would. Thank you very much. Thank you. Approved. The simplest thing I can share is this device with a 48-volt power supply, and there are 8 inside. It has a water sensor. You can make any shape for it, even with a toilet valve so water can flow in. But it's better to use water from an osmosis filter or everything gets dusty. When the water runs out, it refills here. Go ahead, film slowly. Yeah, can I show this to you? So what you see here is a Soviet press, which is a type of industrial machine built during the Soviet era. This particular press is designed to apply a force of 150 tons, which is a tremendous amount of pressure, enough to crush or shape very strong materials. Now let's look at another press. However, this one isn't as advanced as the first. The previous press can handle larger samples and more demanding tasks. Here you can see some crushed rebar, which is still reinforcement bar that has been compressed by the press, showing just how powerful these machines are. Let's continue.
Is that okay?
Are they strong? It's almost a kilogram per cubic meter. That's decent.
Is it okay to use carbon fiber cuttings? Is it simpler? Density is about 1 kilogram per cubic meter.
It is finely dispersed and mixed as well.
Oh, so the main thing is to mix it well. Yes, but the question is what kind of mixtures? It's hard to lay it somewhere.
So now,
we're about to get into delivery with you. When you make them, they become non-technological, immobile, and it's hard to lay them anywhere. But this is something small and durable, something you could use even in a fairly dusty workspace. We're in one of the technological laboratories, and this is where the mixing happens. And so, more or less, ideally, if we use metal molds made in Russia, they should be polished and made from sufficiently thick metal. Let's discuss the molds. Russian-made metal molds should be thick, polished, and clearly marked, since they're split molds that need precise assembly.
are they sold at the present time?
We have them custom made by the company Contras, but in general, you can buy them without
any problem, you know? Look,
and for high strength concrete, we now recommend everywhere in the standards. This is for large
samples,
This is, as you can see, a non-split.
a plastic mold designed for a pot. This is
For the mold, well,
For now.
test these fists that you see.
this is
The basic sample.
15 by 15 by 15 with an edge. This particular sample measures 100 by 100 millimeters. This is what is known as a non-split mold. That means its dimensions are always fixed and unchanging, so the faces remain consistently parallel and perpendicular to each other, and accordingly the sample size is always exactly the same. It is thoroughly blown out with a compressor and then carefully removed. These are high-quality Italian molds. There are also some German ones available as well. And that's how the cubes turn out. This is only the side from.
Concrete paving mold.
This is leftover concrete from material testing, made with any available strength after people brought in materials for tests.
In fact, we
We don't want to throw it away, so we pour.
leftover concrete into tile molds. Might help.
Well, yes, actually, our question will also be
About, oh, well, this is actually,
Smooth. Well, it needs some finishing.
yes, actually another interesting thing we're trying. In fact,
Is to make these. This is actually made from white cement. And what does white cement really mean? White cement? Yes. It has
there's no iron.
just without iron, such as
And what exactly do you do with this then? It's just so incredibly beautiful, isn't it?
like
Lay it out as a mosaic like gypsum.
right? Yes, it looks like gypsum. So, well, here we can.
Add pigments,
The pigments are also based on some metal salts, right? These are titanium dioxides.
iron. Titanium dioxides are white, so iron looks black. You can etch iron with hydrochloric acid.
And it turns out so beautiful. Yes, you can. Basically, you can experiment with anything here. Here we have mixers for quickly mixing various solutions. You put a bucket here, it spins, and the blades mix the contents. That's what this is for.
German, our workhorse.
Aha, super mixers.
It slowly and gently lowers down.
The head now, the blades spin. On
Here,
you put
the vat.
this lab mixer, modeled after our German industrial design, handles both dry and liquid additives.
And what is this? If it's not a secret, if you don't mind me asking.
Rebar and rebar, that's a pedestal. A pedestal. We made the pedestal for our own various purposes. Then we were approached
By a company,
called PIC, which aimed to further reinforce the connections between the panels, insert a strong and sturdy rebar frame there, and carefully pour in grout in order to strengthen the joint even more. Accordingly, we simulated the space between the panels with a pipe like this, inserted a rebar frame inside. To reinforce the joints between panels, insert a rebar frame there, and pour in grout to strengthen the joint.
so we,
They simulated the panel gap with a pipe, added rebar, poured the mix, and checked the results.
whether it bonds,
Or not bond monolithically. Did it work out? Yes, everything went well for them. All this they.
all right, understood. So those were the questions we wanted to ask. Mikhail, what did you want to ask?
The question is, can we try to develop these panels? Is this glass?
Glass fiber concrete. Is it possible? What about the thickness specifically? Look, you need to specify the minimum thickness we need. It depends on the length. The main task is that it shouldn't be load-bearing as such. It's just to provide for facade cladding. There is just glass fiber reinforced concrete. We don't need complex shapes. We don't need like...
What's it called? To be sprayed on?
Just
mix and pour. The slab should be at least 2 meters. Don't worry about small details. We've had cases, for example, when we needed it for a parking lot. It undergoes a lot of deformation. It starts to warp. We've had cases, for example, when we needed to pour floors in a parking lot, and the thickness ranged from 1 to 4 centimeters, with a slope of about 1 centimeter. What happened? Everything was prepared, the floors were poured, we cut them into sections to relieve the stress. A few days go by, and the floor...
But how do they pour countertops then?
Countertops of a certain thickness, for example, can certainly withstand grinding. It just comes off. You can lift it up like a sheet. Countertops are poured thick, can handle this and get ground down. You can install countertops anywhere.
And make it, but it's different when you lay tiles. Everything is like this. So how do they pour those? Do they just spray them? No, they make them on the panel, and concrete ones too. They make them flush. Maybe...
Clamp them? No. What panels? Facade panels. They make small ones, even by extrusion.
These are fiber cement panels, so they mix cement in there.
Cellulose fiber? No. These are glass fiber reinforced concrete. People came to us because after pouring and hanging tiles on the facade, things seem fine. But when it gets hot and sunny, the tiles warp. The tiles get ripped out from under the system, fall onto cars, and break from the heat. So that's the issue here. We worked with a company called Toshir. A long time ago, they adopted American technology. They used extrusion to press out these panels. So an extruded strip would come out, then they'd send it to a dryer and could use a printer to apply different patterns to it. After that, they'd cut it into tiles of the required format. But again, that's an extruder, and
I see. Well, okay.
and you,
For example, with casting, what size can you reach before it warps? Like a 30 by 30 tile. How do they make bigger ones? Tolian, there's a picture. They make them somehow, right? They use two technologies, casting or rovings.
they use fiberglass with rovings and pour cement over it. Well, that's another technology too. There's a special machine, like a little hut, that applies layers 2 millimeters thick, rolling them out layer by layer. But even then, they make these panels about 1.5 by 2 meters, stack them up, put them under a load, and let them harden for several weeks to remove any deformations. But I don't know how efficient or fast that process really is. So it's probably easier, It seems to me that it's generally easier and also a bit more affordable or cheaper to simply take a similar size panel made from some other materials.
Not from concrete, not from any tangible or physical material, but not from
Concrete, such as...
You end up with concrete, it looks nice and all, but it's not white, it's gray for now.
So that's exactly what you need. Like in kitchens, they usually cast these kinds of things for me, just to be sure.
But that's a certain size, that's reinforcement though. Well, no.
It's reinforced, you know, Tolya. If you reinforce it with mesh, obviously it won't sag at all. Plus, you have these transitions. Basically, the corner, it relieves the stress. It's a compensator. We even have issues, look, in both European standards and American standards, and in ours too, if you pay close attention, for example, to non-reinforced slabs like the ones we have now. There's a lot of work. A lot of airports are being built now. A lot of runways are being laid. Here's the technology for constructing the pavement. A machine, either 7.5 meters or 15 meters wide, pours a strip that's 40 centimeters thick. It's unreinforced, 40 centimeters. So it's this kind of strip. It runs. If it's 7.5 meters, then every 7.5 meters, once the concrete has just set, saw cuts are made. They cut this strip every 7.5 meters. Why is this done? It's to relieve stress so that any cracking happens exactly at this cut. This cut is then carefully sealed. But if you don't make the cut, cracks will appear randomly and
Well, you remember when we were pouring and tried out that crap we had or whatever it was,
it turned out, and on a long piece I bent it. You can't bend it at a certain length. At least 1 meter, maybe 80 centimeters. 1 meter is the limit at 15 to 18 centimeters. No, the whole thing right out of the box. It'll be like a sheet. Wet a sheet and dry it. It'll start to bend. If we press it into the window, keep it there for about 2 weeks. It'll...
Only with autoclave? What pressure?
That needs checking. Talk to the people who make them. Is it 8 atmospheres?
No, not at all. We actually just happen to have an autoclave here. I think 2 will be enough.
We have a 3-meter autoclave. Let's test it on wood.
Where should we be looking? Could you develop a formula for some kind of monetary reward? We don't know, so you'll need to experiment a little, but we'll be searching for half our lives. We need to decide if it's better to use glass fiber or regular fiber. The less water in the mix, the less it will shrink. Where should we be looking? Could you help us with the formula?
Can you develop it for us for a reward? It'll catch on things, right?
I think it'll start to rust and stain everything orange.
It will.
All right then, so sitits. There's acid-resistant fiberglass available, right?
If you use all of that, it will rust and stain absolutely everything around it orange. So that's why there's acid-resistant fiberglass available, right? That's exactly what you need here because hydrochloric acid reacts with iron and it starts turning into ferric chloride, which is the compound that gives it that distinctive orange color, right?
No, it tints it, that's clear.
But what if, for example,
We use concrete or panels inside, keeping a consistent style. Sometimes control elements are made thicker. With voids, roughly speaking, you can make it with ribs. Yes, with ribs. The ribs will help relieve the stress through themselves.
We can simply pour it after all. It's really not that difficult. We can pour
it right away, something like that. Cut it from MDF. How do you make these voids? Form them so you have a rib. So you need to
create or make some kind of voids. We'll cut it on the CNC machine. Yes, that's not a problem for us.
With that kind of air,
We'll take it from there.
We could try it in principle, yes. Well,
We just need to determine on the mix because what exactly are we doing and how do we steam it, basically?
we can use an autoclave.
to steam it, right? Yes, why not in the transport chamber? It's better in the autoclave.
The processes will just go faster there. In
Principle for the slab, the autoclave isn't needed, is just to experiment faster so that
We don't have to wait. Why? We have the right mixes, that's not a problem. I've written it down, the only question is to try it. If you're ready to try, you can use glass fiber, you can
use carbon fiber for,
or use basalt fiber. That's available too.
go ahead. We need the mixes. All of this is just so, roughly speaking, your unreinforced panel does not break during transport. It is not intended for any load-bearing capacity. No, we do not need it to be load-bearing at all.
And the main thing is that, you see, the fiber really shouldn't be so that it doesn't...
it gets mixed into the dry mix and it is distributed thoroughly throughout so that it spreads evenly. And that's it. Then the only question that remains is to carefully find the right dosage or amount of this particular fiber so that your mix is actually workable and easy to handle. When making the mold, just mix in the fiber wet or dry so it spreads evenly. Then find the right amount to use.
How do you pour beneath a caisson?
You want it centered. If not, is it at the bottom?
with these, like with cubes. The caisson, there will be a caisson at the bottom.
The pouring will be from the top, but what about the surface then?
It'll be smooth on top, and who really cares about the bottom?
Won't look good on the bottom. I think you should grind it. We have a good surface, we just pour it, and we insert the caisson. I put in
A sheet with caissons. First pour, then the sheet with
lay it out with caissons. The sheet with caissons and vibrations, they'll sink in.
trim excess.
Why can't you make it straight from the bottom? Well, your
Front.
side will be as follows. Now please, just like this.
The front side is wrong and needs sanding, but I don't want to. Should we use plywood or pipe to fix it?
Vibrate metal.
Remove frames with air.
They do know you are making... Oh, trapezoidal?
Oh, and then maybe there won't be any stress? Yes, but there will be ribs. We'll take it, and it'll turn out...
Thicker. And
Will the facing only help us? Well, yes, of course. Come on, Misha, try to really think of something helpful. We can do it. Based on
the results of the experiments, he
should do it, whether it's completely free of charge or not. That's
not even up for discussion. It's if you're interested.
We're very interested. We need this. I want to start working on my dot dome right away.
We can just brainstorm together. Yes?
It's just a matter of time. We can prepare. We can film Dasha with this thing. We'll shoot him a long video. That's all this is about right now. If you're interested, we're very interested.
We need this. I want to start my house soon. Let's brainstorm, prepare, and film. It's just a matter of time.
A long video for him shows what we achieve and dislike. You can visit us on a set day and bring elements. They have ideas. We need to make it metal. Think. Then you'll consult and help mix. And there, at that very place, something important was about to happen, marking a turning point in the story.
About
Hey, start small.
we need a strong, thin formula. I'm telling you, the sun has risen. The thing is, the stronger the material, the more brittle it is. More brittle, well, it's something in between.
Is there brittleness on the wall? The sun's up, deformation started, panel heated up.
It cracked and hit someone. Anyway, it happened. We got up, checked TPR in the meter, entered, and they fell out. With concrete, especially dark types, you notice it drying.
Well, you have to impregnate it, right?
Yes, on it.
It will start.
White dried spots will appear. And dark concrete, well, that's just the regular one. This one is unusual. This one is just the regular one, just regular.
And this one too, it's already a little bit unusual. Salts as well. But it's fine, so what? We actually want it to look nice with all sorts of streaks.
That's even better. To brighten it up, yes, pigments. There they are, those little cups maybe. Bay Ferox, a black pigment.
No.
It reduces the strength.
Ah, I see.
So here, as you can see, the Chinese make it very carefully. It is extremely finely and evenly dispersed in appearance. Like
Toner.
right? Yes, and black soot you don't add? No, it weakens it. Got it. So here the Chinese make it.
Carefully, it's finely dispersed like toner. Yes. Bayferox is iron. The reddish Taliana is treated with hydrochloric acid, making it like this. That's from ferric chloride. Somehow makes it even stronger. Oh, wow. Titanium dioxide. Well, that's clear. Titanium dioxide is commonly used everywhere. You can even add it to regular concrete. It'll just become more noticeably white. Yes, lighter. By the way, gentlemen, titanium dioxide is actually even used in toothpaste. 85% of all titanium goes into making titanium dioxide. What? Well, if you want, I'll take some. It's not toxic. Why won't you let him eat it? No, I'm not going to eat titanium dioxide. That's it. It's safe. It's even used in toothpaste.
Ah,
See, you can see that it's getting lighter now.
titanium dioxide is commonly added to white cement to make it even whiter because titanium dioxide is safe and even found in toothpaste. It's used in white cement to make it whiter, but not with gray cement. You take titanium dioxide powder, and it's better to add it dry, specifically to the aggregate. You color the aggregate, use white cement, and everything turns out well. You get something like this, all white. This evenly white one is with titanium dioxide. Here's a reddish-gray mix. Add titanium dioxide dry to the aggregate, tint the aggregate, use white cement, and everything works out. You get this white result.
This one is white.
Titanium dioxide. There's also marble chips here, which makes it strong. Yes, it's quite durable, but the size is still... No, you can make it with caissons. Yes, caissons to relieve stress with ribs. But we've tried it, and what we're interested in now, let's focus on that. The recipes will help us, and we'll figure out the caissons for the culture here.
Yeah, we'll pour the thing in.
The mold is cool too. We'll see it on the sausage. Oh, that's good. Then I'll do it myself at home.
As a general rule for the fastening subsystem, what facade workers typically do is that they basically mold tiles of a certain size and then immediately insert the embedded parts right there on the spot.
That's good. We'll define good, show fastener use with ribs, tile molding, and interest in the recipe. We poured concrete near the NIIZhB. If you've been there, well, you haven't. Come visit and see. There are some flaws in the concrete. It's regular concrete. We also added heating. We have heating on the return line with an HDPE pipe. The top layer started to flake and break apart. We'll think about what to do. First, what can be done? I have an idea. Use a kercher to knock out what's loose. If it comes off deep, try pouring more with a reinforcing mesh. If it's not too deep, try using
that fine washed crushed stone, or what? Not fine, granite. You know, when they use polyurethane, like epoxy, well, either epoxy or polyurethane, it still has some flexibility and it will protect it from moisture.
There's a risk that the old concrete and the new material will actually have different coefficients of thermal expansion. But what's the main advantage here exactly?
Specifically with polyurethane, not epoxy, it makes a lot of sense. It's like how they make park paths. They tamp down the sand and lay it right on top so it ends up with a kind of drainage layer. That means water can pass through it, right?
Polyurethane is hermetic and won't crack, while epoxy is brittle and likely to break. Still, if I were you, I'd reinforce it by tying the layers together with rebar.
Yeah, sure.
Just hammer in some pins, some anchors there, and then carefully lay mesh over them for extra reinforcement so that everything just doesn't delaminate.
To make the anchoring, yeah, hammer in some anchor pins and lay mesh over them
so that everything just simply
doesn't peel off. Maybe use the finest
one, not plastic, but
metal. Plastic works too. Anchoring, no need. What could we have a big concrete area? Yeah, after winter, right? After
the winter. And did you pour the concrete yourselves? No, we didn't pour the concrete ourselves. We bought it instead because it was more convenient for us.
What kind of concrete did you actually buy? The foreman says we need
concrete, this type of concrete, like a 260. For things like this on outdoor sites, especially where cars drive and bring in de-icing chemicals on their tires, you always need to use concrete at concrete plants. They'll understand the phrase concrete for bridge structures. That is, they test it for frost resistance in salt, and air entraining additives are added to it. What's the point of an air entraining additive? So you add a certain polymer. Concrete for bridges is designed for high frost resistance, especially in salty conditions. Air entraining additives, like certain polymers, are mixed in to create tiny air pores, improving durability. It creates a microporous structure. When the concrete hardens, it ends up being full of micropores. These pores act as dampers. A crack can form during the process. Some of these pores are larger, but overall it creates a microporous structure. When the concrete hardens, it basically ends up full of these micro
pores. These pores act as damper.
A crack forms during the process and it enters the pore like glass.
If you drill in, this happens. The crack runs and hits a pore.
It gets sealed up, well, so that it doesn't keep spreading. So, for example, we don't use highly durable concretes near the vibrating additives, simply because nothing can penetrate them. Neither chlorides nor water.
Well, let me see.
They have a high waterproofing rating, so absolutely nothing gets in there at all.
High-strength concrete resists water and chlorides, so air and training additives aren't needed. For roads, we can add what we need.
There's a pretty good one. What we need is a recipe so that it definitely doesn't crumble. Well, you need... Here's the question for you.
You just need to, as an example,
use an air and training additive. You don't need extra strong concrete. Class B35 or B40 is enough, and you can buy or mix it. Add the additive in the right amount, measure the air content once, and you're done. You can then just interpolate by density. It won't fall apart, you just need to do it, that's all. The main mistake people make is, roughly speaking, like you said, let me just take something simpler and the problem will go away. It won't go away. Here you need a certain amount, which is also regulated. You can then just interpolate by density.
it won't fall apart. You just need to do it. The main mistake people make, roughly speaking, is like you said, let me take something stronger and the problem will go away.
The problem won't fix itself. Use granite crushed stone, an air and training additive, and quality cement to solve it. I can tell you right now, an air and training additive, good quality cement.
Can you somehow develop this recipe? I can share it with you right now. Today I went to our company sites. I'm ready to...
In working
Condition, I understand now.
It's what's considered good and what's seen as bad. Let's mix it all together.
Yes.
What did you...
Bring. That's it. Cement, additive, MP, MB.
We won't advertise it. So what's the trick? When mixing, air is gradually incorporated into the mixture. As a result, it forms a stable foam. Air and training additives in concrete trap tiny air bubbles, creating microporosity similar to foam. Here, take a closer look. Which one do you want? These are all different additives for different purposes. Yes, here, what I mean is, when we make concrete, everyone says, well, give us an additive for concrete. Give us some kind of additive. Take a look. Which one do you want? These are all different additives for different purposes. So all of these, and here as well, accordingly. Secret. No, you can't use aluminum. Kaison? No, there are heat-resistant ones, and there are thermally resistant ones.
Use heat-resistant concrete with perlite for aluminum molds. Temperature isn't critical.
Concrete, you can use that too. Concrete could have been used, it still burns through.
It will still slowly burn through, just over a very long time.
You print it on a 3D printer, cast it in concrete, dissolve the printed part with lemonella, and you end up with a basically finished mold.
One suits your needs.
Reusable with varying amounts. Of course, but how do they make concrete for grates, pipes, and other things? There are tasks, for example,
The launch pad table at the Cosmodrome. Rockets take off there using heat-resistant concrete. I don't know how heat-resistant. They patch it with mastic after. We were there.
the gas duct. How much does it withstand? Well, it flakes off, yes, a layer peels away. The question here is how long this temperature is applied. The whole issue always comes down to the duration of exposure. We once had a negative experience like that. Some people from the bridge construction team, exposure time is crucial. Sometimes another layer is damaged. For example, bridge engineers had issues when we replaced cast iron parts. Metal elements for bridges to reinforce the bridges for supports on concrete. We made exact copies of these out of fiber reinforced concrete. Metal bridge elements reinforce the bridges, supporting them on concrete. We made exact copies of these parts from fiber reinforced concrete. They made one hinge with these curved aluminum plates. For a long time, we couldn't figure it out. We poured the concrete and it seemed to expand and rise, pushing out a lot. Somehow, we managed to deal with it. The next day, we couldn't open it. When concrete contacts aluminum, air forms and hydrogen is released. You can't do that. Concrete
With aluminum, there is the gradual formation, which is part of the process.
Of the surrounding air in the environment, and
Hydrogen is released as part of the overall process. This
should not be done, and under normal circumstances,
aluminum powders are present there, well, and they are known for their distinctive characteristics, which make them useful in various applications.
So, well, here we are now. Let us take a look. I see, I see. And we also wanted to ask.
So,
with
this
concrete, can you tell us the recipe?
Pouring 150 cubic meters of concrete turned the path to mush. It was unpleasant, likely due to winter, not calcium chloride, which wasn't used nearby.
There's also the question of, roughly speaking, what the area is. I told you about the cuts, and both roads
And walkways. They need to be divided into sections. By the way, there was something between them.
separated aluminum, they supplied it.
It could be polished, not related to the inspection.
Not the inspection? Why not? It is indeed an inspection. And they leveled it, and it turned out really well. They
Polished this road twice, soaked it with lit seal stuff.
but nothing helped at all.
At all. No.
Here you need to try it. Yes, give it a try right now.
Try pouring normal concrete. Go ahead and try, but it's already weak. But the main thing is to make sure it doesn't get into this
Joint, so that water doesn't get in between this pad and the concrete surface, ensuring it is sealed properly. Pad and
concrete. Polyurethane. If primed, this uneven part crumbles. If water gets in, it'll break apart in winter, so it worsens. At least this can be fixed. Or I could cover it all with polyurea, but that's costly. I like this material most. All flat roofs use it.
polyurea will never leak.
Well, that's expensive, yeah. But we have a cheap setup.
the problem is the road, not the equipment.
There are special engineers, I'll put it bluntly, scam artists, who know exactly how to make things fall apart right on schedule.
Honestly, the real problem with any construction project is oversight. Wherever you go, it's really all about oversight, because there are a considerable number of people, or maybe it's just our mentality and human nature that everyone wants to. It's not just about stolen money, the real problem is oversight. Even with skilled engineers, things can go wrong if no one is watching. It's often human nature, not just deception, that leads to these issues.
About getting things done faster and more efficiently. Maybe in your daily routine.
We each have our own production style. For me, it's the cubes. I've checked everything. Now we just consider possible changes.
There's
The double safety margin, as everyone says, just in case. Or, for example, there are certain construction technologies. In Germany, for instance, they stop building with certain methods when the temperature drops below plus 5 degrees. Here, that's impossible. Our construction sites would just sit idle. So for us, well, it's like there's winter concreting, which requires specific procedures. Some people are too lazy to do it. Others try to save money on diesel fuel.
Construction sites keep circuits warm and covered above 5 degrees Celsius. I saw this at Taganka with penthouses. There was some kind of beam lying there. It was sort of separated. And a terrace was supposed to be built. There was some kind of beam lying there. It was kind of separated.
They found a bundle of 12mm rebar still in its packaging, thrown into the terrace and covered with concrete. It made no sense. Doesn't really care. So it has to be poured on Saturday. Here's a recent case. It's winter, that's it. They say, well, we need to clean up there. That's it, doesn't care. He comes on Saturday and says, I ordered concrete, the concrete will be here in an hour, but we're not ready. The slab wasn't poured, but the client insisted it be done Saturday, even with snow and the site unready. He ordered concrete, and the crew poured it on the snow as told. Well, as we usually say, there is nothing here for now. However, at this point, we also need to take a closer look and carefully inspect it as well.
Money, time, repairs, it gets absurd. Next to me, a guy rushes up. I'm building a house. First snow just fell. Concrete's coming. How do I keep the foundation warm? He has 60 cubic meters. I tell him, you can't keep it warm now. I turn the truck and say, no, you have to pour it. We can't help you. That was in the fall. Foam concrete.
Unfortunately, the person we were talking to is currently on vacation at the moment, but he will be back soon. Right now, he's interested.
Because they want such a high price. Do you remember how much? 2 trillion more than regular, and it's a large volume.
No, this is a lab that deals only with lightweight concrete. He'll give advice, no problem. The main thing is,
appearance doesn't matter. Foam concrete is costly. Expert advice will help. We finally found a designer from the precast concrete plant who unusually calculated it for us with columns so the column would merge into the structure. Part of the structure, T-shaped design.
This is how it turns out.
So it goes like this. Here's a wall, then a reinforced extension, then it...
Well, those are called pylons.
That's right, pylons. Yes, pylons. He calculated everything, says it's fine, it's okay. He mentioned the wall. Yes, you can move it, start a little bit. No, but let me explain in a bit more detail if you don't mind.
You can, if you pour it into permanent formwork, you'll tie it together into removable formwork.
You can arrange or connect things as you like. It's up to you. You can connect blocks or use ties. Pouring concrete in removable formwork creates a wall with outlets, but it wasn't counted as load-bearing. He counted it because, well, honestly, who really knows how to calculate it? But just in case, he did it anyway.
No, especially if you want to do it there and...
The expectations matched up with the bits, yes, because
with the foam for...
it floats up for you.
It's just a pain to cram it in, and after all, it's still considered a fire hazardous construction. That's 100%. It's non-combustible, so any certification... So I use 200 grade, 150 grade pure concrete. That's how the Germans do it. I started looking into it, but to me, it's still... It's not perfect. It doesn't provide wind protection or waterproofing. Everything inside stays there forever. In short, I don't know. Mineral wool also settles. I've seen this myself. Here's a house that stood for 10 years, and at the corners it starts to sag anyway, because it settles, no matter what anyone says about PIR. PIR burns. Don't call it non-combustible. You'll just die if it catches fire. And it costs a lot now.
Well, there was a facade fire recently somewhere in Tver. Did you see that video? On Ivanovichkina Street, right by my place?
A window. The tower caught fire twice there, you know. The facade is clad in aluminum, and inside there is a material called polyethylene. These are known as composite panels. Someone was cutting with an angle grinder, and the wind protection material was flammable, which is why it happened. It caught fire just like paper. Fortunately, the hydrants worked, and the firefighters arrived quickly.
But that's the thing. Everything is supposed to be non-combustible, right?
I mean, if you poke at it, everything will burn, but Penoblock doesn't burn at all. There's simply nothing to burn. Everything is poured with concrete. I'm telling you, that's the right way. But what is this they've come up with here? Back then, everything was built just fine. Why did they come up with this idea of using some kind of foam plastic?
No, they're doing some interesting things now. Wooden structures?
Wood is better because it's just always in motion, constantly adapting to its environment, and it's truly a unique and remarkable material. They built a beautiful chalet, right? For comfortable, permanent living.
But we can go take a look, of course. Right now, we can't really film there due to restrictions. It's not really our area. But over there, they actually have wooden structures that are being tested for high-rise buildings already. I can, but right now, at the moment, there is a trend towards wooden construction.
I just don't...
I know why. No, there are designs. For example, if you look at the Aquatics Palace in Kazan, which was built for the Universiade, there are very beautiful beams there, bent. They are in the form of a console, made in the shape of a wave.
It's beautiful in Rio Tewi, same.
Yes, that too.
That sports complex too, they have bent structures made of glued
Wood, yes, exactly.
I would say that making such large and complex structures is not cheap at all, and even though it's wood, it still shifts and moves back and forth over time.
But you really need to talk to specialists about this, because here you don't need to. We used to build out of concrete.
No,
He came to us.
even now some people have boats, like someone has a yacht made of concrete. Well, it's really like that, you know, made of concrete, reinforced and super strong and durable, just like concrete is made, really.
Yes, but just recently a man came to us. He carefully built a boat by himself and even sailed on it.
Some Americans sailed to Antarctica. Well,
There are many of them. Another one came recently. He was also planning to go to a regatta. How did he do it? He had mesh. Basically, he would take a mixture, then mesh, then mixture, then mesh. It was a layered process. That's possible.
but basically, its seaworthiness will be worse, the volume will sink, everything will be worse than, well,
Probably, of course.
on the other hand, of course, you just grab some Maymac and lipstick, plaster it on. The best ones are like aluminum. They're even better than those composite ones. Much better for the sea. That's the minimum. And actually...
If you want to see the explosion effect for yourself, just watch how real high-strength concrete is tested. But you really have to be close by. You can't stand far away. And now, we'll go and make a call. Who is that? This? This is real B100 concrete, which we made in St. Petersburg. It will be used for the construction of Lacta 2 and Lacta 3. Oh!
Can I try it? It's pretty heavy. Yeah.
There were certain requirements here. It had to be not just B100, but also have some other specific characteristics. So basically, it's a mix that was tested in production. And now we're going to take it to where we have a more powerful press. All the towers in Moscow City, as well as our laboratories and the institute as a whole, indeed, really. And the question arose, roughly speaking, which concrete to use, right? And he says, let's make B90 concrete. There were no standards. We just wanted to do it. Yeah, he says they do it abroad, after all, and we want to as well. Can you do it? Our manager says we can. The designers are shocked. How, what, where, how does it work? Calculate it, right? So they did the calculations. What will the column cross-section be? Well, the column will have this cross-section. And what concrete are we using now? Right now it's B60. What's the current column cross-section? Now it's bigger. He says, now please calculate for me the total area in square meters that I can sell. From these columns, concrete will cost more, right? By how much? About 3,000 rubles. He says, calculate the square meter due to the reduced cross-section. He calculates, says, estimate it based on the market. He estimates and says, that's it.
If we had used smaller columns, they would be better.
We made 90s. Federation Tower columns were 90s concrete. Well,
Yeah, definitely at that price.
just by someone's willful decision. There are no standards, nothing.
That's the right approach.
Here, I don't know if you'll be able to hear it or not. This is the climate testing hall. There are different freezers here. So is this exactly where they test the concrete for frost resistance?
Oh, I see. All right.
No, that's a freezer.
That's a freezer.
Convenient 8-cube freezer.
And until what point do they freeze?
Up to about minus 50 degrees Celsius. There is a structure with insulation there now. They are testing it. Yeah. What do they give? Well, the structure is worth it. It's... In short, I am specifically referring to freezers here as an example. This is probably exactly what happened to you with concrete, right? With your deer. It looks like only the big ones fall off. Well, that's it. That's frost destruction. That's what frost damage looks like. Got it. And here we are carefully and thoroughly patching it up, making sure to seal every gap so there won't be any more frost. They'll give us a formula so the new ones won't have this crap. So besides the formula, there's a lot more. But I already said, like, no, but well, for me, we already talked about it. We keep saying that we'll patch it up and make a new one of these. Well, then we'll need a lot. Oh, is that good? Well, I don't know. I'll find out now. Count it. Maybe it's even better. This is our old, reliable, and dependable machine from Soviet times, which has served us well. And at what second? Huh? And at what second will it explode? That I can't tell you. I can give you an approximate idea of when it'll happen. Should we run away or something? You'd better stand farther away. The debris will fly far.
Is it okay like this?
Well, yeah. If it's like this, it's fine.
I can see it. No, like this.
It's not interesting. Oh wow, listen, you know, this is definitely going to be a really great video, right? Seriously. On a slow motion record? Yeah, let's absolutely do it. Should we start it earlier or what? Well, can't it just record continuously? All right, gentlemen, now it's the real B100. We're going all out. Stanislav? Bye for now. We've got about 2 minutes. It's at 900 megapascals now.
About 1,000 or so.
Megapascals. It's definitely still holding.
1,100. Exactly 1,300.
Wow, it really overperformed. 1,300. That's a much higher result than we expected, and it's honestly quite impressive. Oh wow, Geo. Unbelievable. Impressive. Look, it left a perfectly even little pyramid. There it is, a perfect little pyramid. Just like your 3 fingers, right?
1,400, which is the number 1,400, that is to say 1400.
Right? 1,361 kilonewtons. Well, that's about 130 megapascals.
Wow, that's incredible.
If someone tells you that BST concrete doesn't exist,
Spit in your face, right?
here it is now, here it is.
Now, someone else, a real pro, has done these kinds of tests, right? We didn't do it ourselves.
No, but we do solve these kinds of problems. We've been making high-strength concrete for years. Millions of cubic meters of concrete have been poured. If before, in Moscow, the highest class of concrete was, let's say, B40, and even that you had to really search for at concrete plants. But now, you can just call up a concrete plant, well, not every single one, but certain concrete plants, and order BST concrete. They'll deliver a ready-mix batch to you in a mixer, no problem at all. But it's a specific process. No, it's not just a ready mix. It requires certain additives, a particular approach. There are different ways to make it, and in general, well, many do it, but there's another issue as well. It's about producing the concrete, delivering it to the construction site, placing it into the structure, and achieving the required strength in the structure itself, not just in a test cube.
People actually used to have a kind of substitute material for concrete. Yes, that really does happen, and it happens literally within just about a month. which is quite surprising.
It will. Yes, no problem. We tried fiber-reinforced concrete and high-strength concrete with you. No questions about it.
And this is
Yes, this is... The fiber doesn't shatter.
incredible. The fiber, it just cracked. It is perfect for the pyramid shape. The pressure is distributed evenly.
Well, the bottom one shattered, but this one here... This is classic failure.
Wow. Not every type of granite, as you might expect, can actually withstand that.
No, granite can generally handle such strength. Well, here it's basalt.
Basalt?
Right? Yes, basalt crushed stone. But it's not for strength, it's for other purposes.
So if it was just for strength, it would just be regular concrete, right?
Yes, high strength and ultra high strength concrete are mostly made without crushed stone.
And if you recalculate it, how much load was that per cubic meter in tons?
Exactly 136.
Well, that worked out great here.
136 tons we're pressing right now on an area of 10 square centimeters.
No, we are actually in Russia. Clearly, it's all not serious.
So, well,
A scientist experimenter in Kazakhstan. There's a whole row of test tubes.
and when it forms here, this method of determining the water resistance of concrete is called the wet spot method. What's it about? A sample is placed and pressure is applied. Right now, it's 4 atmospheres. It's held in several stages, I think for about 14 or maybe even 16 hours. Or honestly, I don't remember exactly right now. And at each specific interval, pressure is applied with a step of 2 atmospheres. For example, if it holds at this moment, that means it has already passed at 4. Next will be 6, and if it holds at 6, it passes again. And why is it called the wet spot? As soon as a wet spot appears here, that means the water has broken through, right?
What about all those, there are these hydrophobic additives, like,
NIIZhB, they perhaps...
do they make sense? Do they reduce the strength? I tried mixing them in back then.
No, there are...
Water-soluble ones, some that aren't the ones you mix with gelatin.
Here, by the way, everything is pretty primitive.
Cache. Only now it's easier, you'll just need a pump.
No, well, it's...
By the way, the Kerker actually pushes the pressure just fine there.
I mean, it gets up to 20 atmospheres here. Our highest class for water resistance is W20, and it holds
20.
It holds 20, yes. Well, this one probably won't hold up, judging by the color. But in general, high-strength concrete can withstand 20 atmospheres. Well,
I mean, for us, like I said, if we're really making a pathway outside, it should have a higher double...
no, it doesn't have to be. You don't have those kinds of pressures there for that. In the atmosphere, there aren't any. In nature, there aren't such pressures for that. Well,
Like, take a dam, right?
dams are actually built on a different principle. Dams are made specifically, with seams at different levels. And that's all.
So, infiltration, right? That's, well...
So it's not really about that. We actually produce concrete in our work, let's put it that way. There can't really be a reservoir here, right? That's just another indicator. Its durability, yes, it doesn't actually absorb anything at all, so it never gets saturated, and then there are salt mists, those salt mist conditions. The presence of salt in the air, salt mist, can be quite significant. So this is corrosion. There's actually a whole hall here dedicated to corrosion. Here it's reinforcement corrosion.
Remind me, they created humidity by adding moisture to the air, which made the environment more comfortable and pleasant for everyone. At some point, we took oil paints from the tank and basically recreated the bio effect, and now we were giving it an economic value.
Here too, there's a coating. Here's the paint. So it eats it away, right? Depending on the operating conditions.
By the way, Kostya actually made a truly hellish chamber and ended up burning out the lamp. This one right here, yes, this very lamp burned out. Everything was residential.
This is a rather brittle material by itself. It is actually considered to be one of the least durable materials in the cement system. This becomes a problem, especially when there is a significant amount of it present. We create concrete modifiers. We modify the internal structure, which helps to strengthen the structure of the cement stone. Because we have CO2 present there, it binds the ring.
And by the way, when you use liquid glass, it separates, but does the strength decrease?
Yes, it decreases.
I just tried it out for fun, mixed it about 50-50 with water to patch something up quickly.
No, you can. There are hydraulic plugs. For example, when there are leaks, they make special hydraulic plugs to seal them, but it's not long lasting. That's all. Let me take a look here. Unfortunately, it's closed over there. Our press is quite old, but look, we can walk through. We probably won't be able to film in those workshops, but we can just walk around and see what we have. Yeah, and now we just need to mix a small batch or two. In a month or so, the material needs to be replaced. That's how it was actually done. You see B60, still going, right? Soup. We can go into that hall. This is the chamber for proper concrete storage. The raw material is here. Yeah, just ask security to let you in and out. Here are the samples stored, gentlemen. That's how it all is. Back and forth. And how is everything maintained in there? There's a humidifier here. Yeah, they pour water in here, and there's an ultrasonic humidifier on top. It just sprays everything. And just behind you, there's a tub with heating elements that also heats the water and actually helps to maintain the temperature. Various structures. Columns can be pressed, different beams too.
And this one, how is it supposed to be here? Not hydraulic, but this one? Well,
It's mechanical, simply electromechanical.
the cups basically are bigger. What's the volume?
That can be loaded in there. You can go up to the full column height.
You can easily crush a column.
Here it's 500.
There's some comfort. It's not just working with a barbell.
No, they keep an eye on it and take care of it. These are two.
Big orchards. And what kind of wonder is this?
It's basically connected to it. That's how it works.
A hydraulic station? No.
An oil station, yes, and it gives it the readings there. Ah, well,
Right now it's just standing there. No.
right now it's just standing there.
No tests are being conducted at the moment.
Well, the beam is just standing there. No, it's not loaded. It's simply been set up. Either it's already been tested or they're going to test it further. That's all.
It hasn't deformed, apparently. Well,
Maybe it hasn't even been tested yet. Maybe it's just been installed for now before the tests. Ah, okay, so it's only been installed for testing. The cats haven't walked on it.
we didn't really end up washing a lot of the clay, and the guys who came from Polyplast didn't wash it either. You mentioned that there wasn't much clay, and everything seemed pretty reasonable to us at the time. We just assumed the crushed stone was dirty.
No, yeah, that's normal crushed stone.
Is there any point in making it out of pure quartz sand like the kind used to make glass?
No, that's already not financially viable from an economic perspective.
They don't make it from glass cullet, do they?
They do, well,
Glass dust or what?
they make it from anything, basically, whatever people have.
So what do they actually use to make it?
Whatever they're trying to recycle, that's what they use to make it.
Slag from a laser process would probably work well. Don't they make it from copper slag?
No, they do make it from slag. Slag from blast furnace granulated slag. Oh no.
But there's this metallic stuff, you know, a lot of it falls off from the laser, those metal scraps.
Well, but how much of it is there?
Not much.
Yeah, it's about the volume here. A lot of people run into the problem that, like you said, yeah, it's a great material, but
Where do you get it? You can get a kilogram.
when people come to build, we need it to be uninterrupted. Listen, we need to...
Just for fun, make some really unusual concrete. Buy it at the Sapphire plant, have about 5,000 carats of this diamond abrasive. It's so expensive just to make this super ultra strong one. With diamond aggregate, by the way, what would happen? I'm just curious what the strength would be. They're not expensive. Remind me of the composition.
The one I gave you, 1,000 carats, 50.
1,000 rubles it might cost, but it's used for polishing. That's cool. Imagine, exceptional concrete with diamond aggregate.
What do they need to be calculated for? Cement, 470. MV80, which is the abbreviation for motor vessel 80, sand 820. Gravel, which is 860, and water, which is 165. So here she is right here. Let me show you. 4.29, MP70, MP80, sand, which is 620, wood chips, which are 660, and water, which is 650.
What? We arrived with a hip. Yes, yes.
We're lying in the car. Yes. Why are you confused about 6.3? Ah, this is my composition. And you pour more.
In essence, we will not change the composition at all. Really? We get twice as much water into the polypolyester.
Let's count now, everyone. Are you ready? 7 liters.
What can you see here? A special thing. Special dinoleum. If there is no soot present, then there is simply no need to tint it at all. Well, as for tinting, okay, you can definitely do it at the very beginning and then tint it. Yeah, it looks really, really nice. You know, you might say, try treating it with hydrochloric acid. It's just absolutely awesome. I actually have some, and I'll show you exactly how. You know, it turns kind of reddish, and it's just, well, anyway. And this is Mikhail. He calculated it, right? No, come on.
So, and this one here is actually 6, but in fact, you usually use more than just 2. Right now, with
the shot, just... And why is the shot used? To make it heavier.
Not for radiation protection.
Cool.
It's for atomic structures, for nuclear power plants.
Yeah, for gamma radiation, it's just your density. Gamma radiation.
Yes. Is absorbed.
And for neutron flux, you need to have hydrogen, either heavy water or polyethylene. Strangely enough.
No, the carbon content should actually be quite high in this case.
I don't know. I know that polyethylene blocks neutron flux.
In neutron, you can't. Absolutely no metal.
Because it will turn into an isotope, become radioactive, and you'll get induced radiation.
It will emit radiation itself. But as far as I know, you really do actually need carbon-containing materials present there.
Remember, radiation always decreases with the square of the distance. Get as far away as possible.
Or make it thicker. Protection.
Do you see those spent fuel pools? How much? About 20 meters of water? They even visibly glow with a distinctive blue light known as Cherenkov radiation. Well, you know, let me see.
It's almost ready.
Just right now.
We try it.
Let's do it right now. Would Uzbeks mix it with a shovel?
No, well, that's hard to mix. With a shovel. Let me show you the 20, that is 25. Give me that sheet. Let's check it. The most important thing to keep in mind when working with concrete is this. The less water you use, the stronger the concrete will be. And all these chemical additives, plasticizers, so-called, they are designed to wetting. Yes, but they have different mechanisms of action. There are, for example, naphthalene-containing additives. These additives have an electrostatic effect, meaning that a shell with the same charge is created around each particle, and as a result, the particles repel each other, so the mixture flows more easily. And here, for example, a polymer additive based on polycarboxylates has a steric effect, and that's how it works. The particles are prevented from coming too close to each other, so they slide past each other, allowing the mixture to remain fluid. And, well, there are different types after all. But not about the hydrated cement grain, right? Yes, that is absolutely correct. Step back a little.
Oh, Masha, look, this is actually from under the door at 1.5. Masha, could you please move aside for a moment? Let's do something together, if you don't mind.
Let's do something. I'll add a little more now. Masha is like right now after the air one. And how was the cement labeled?
Ackerman 600.
No, is it just called Ackerman 600?
Yes, I bought it directly from their dealer, and there was nowhere else to get it.
No, but cement has its own labeling. For example, there's CM142.5N or CM152.5N. Let me see, there's also CM0 and CM2. AI Ash and AKSI. That's what you need to get. Yeah. Something. Let us consider the number, which in this case is 52.
Spline 52, spline.
Well, that means, in other words, its strength is 52, not less than 52, at least 52. I feel a bit embarrassed to ask this particular question about myself, but are we perhaps doing it the other way around, like Oliga French? No, actually, it's just to make it more convenient and easier to use. So you see, you don't have to hold it with just one hand. Otherwise, you would have to stand on it with your feet, which can be awkward. We did comparative tests both ways, and it shows the same spread in the results. So if it flows, and if it doesn't, it simply doesn't. Even if you turn it sideways, did you try that as well? You also made sure with your own can that if it flows, regardless of the method. No matter what you use, the outcome remains the same. But I really can't say that right now. It really flows. Here you can carefully measure the time it takes for this blob to gradually spread out to a total of 50 centimeters in diameter. And that way you can determine the viscosity. But in general, mobility is measured until it comes to a complete stop. Give me the big ruler. Now, just as before, we'll do the same thing with our cement mixture. Carefully make the forms and then check the additive consumption and the resulting strength accordingly.
Go ahead.
The rest. Everything's set up.
How much? 66. Well, okay. 65. Just okay. 66. And how much did you have? 173. Well, it also depends on the temperature.
No, that's not it. Well, he was measuring with a slightly different vessel.
Well, I actually opened it the other way. 65, just as you saw.
65 centimeters.
The same, right?
So, did you end up buying the cone?
Yeah, we bought it.
And did you measure with the cone? No, actually, it must be a very smooth, wetted surface, either a sheet of metal or laminated plywood.
I want it to be more fluid because having a smoother flow would make the experience feel more natural and enjoyable.
Yeah. You want it even more fluid, why?
So that it flows everywhere in the form, which has a lot of embedded parts. So it gets everywhere.
It will flow 70, it will flow 70.
Up to 65, we can easily get that with your exact mix. Getting 61, 65, yeah, that's also definitely possible. But in order to get all the families in there 3, we'd actually have to double it.
But it really can't be that you have to double it, can it?
The additives double, a bucket.
Alright, let's just go ahead and try it now. We'll get the mold ready, so could you please give me a bucket for now? Now everything is the same as before.
Why were you messing around? I sealed it, man. Why were you messing around? I sealed it. Are you spamming?
Let's measure it now.
Ah. But the batting somehow dropped. That's the memory. And only the cement is like that, right?
Everything is the same.
So can you tell me what exactly is this crap anyway?
Hey, Mikhail?
Here, at the CMROS, there was this thing standing here, no matter how much additive you pour in. Listen, but we buy this, the right ones are already being sold. Yeah.
Right now. No, we'll check at Ackerman now, it's actually not bad either. You know what, next time you come to talk about lightweight concrete, bring some more with you.
Okay. And
we'll also try changing the sand. Maybe the sand is too fine, it also traps air and slows things down. Well, just try it out, you know. Where did you get it, by the way? $70.90, yeah.
but the strikers actually ate it and did it wrong. Can't you buy it?
From the same guys? $73 centimeters. And here,
How much? 65 centimeters. And here what happens is we just dump the additives straight in. No,
it's the same here as in Ackerman additives.
but a mobile Führer. This is Novorossis. So gentlemen, I hope you enjoyed it. Subscribe to the channel, give us a like. All the best.